we've already talked about increasing and decreasing functions. I want to formalize it and do a couple of examples so that we know what we're doing here. I think these are obvious definitions. They may or may not be obvious to you. A function is increasing over an interval if the derivative is always positive on that interval, and a function is decreasing over an interval if the derivative is always negative on that interval. It doesn't matter what negative value or what positive value it has. If the derivative is negative, it's decreasing. It's got a negative slope. If the derivative is positive, it's increasing. It has a positive slope. All right? So, well, I thought I had an example. Yes. So, on which intervals is the function increasing and on which intervals is the function decreasing? Now, at what points could a function change from increasing to decreasing? Critical points, right? So anytime the derivative is equal to 0 or anytime the derivative is undefined, those are the places where the derivative may change from positive to negative. Otherwise, the derivative is going to be continuous, and therefore it's going to stay increasing or stay decreasing. If the derivative is not continuous at a point, then that means that it's going to be a critical point. So the first thing we want to do here is locate the critical points. All right, so how do we find critical points? Take the derivative. That's a good start. So f prime of x is equal to
3x squared minus 12x minus 15.
okay, so derivative is equal to 3x squared minus 12x minus 15. And then how do we find critical points? Set that equal to 0. So we'll say 3x squared minus 12x minus 15 equals 0. And how do we solve that? Okay, factor out the 3. So we get 3 times the quantity x squared minus 4x minus 5 equal to 0.
3 times x minus 5 times x plus 1.
So finally, we know that we're going to have critical points at what? X equals 5 and x equals negative 1. Okay? So those critical points there don't tell us anything about whether the function's increasing or decreasing. In fact, what do we know about the function at these 2 points? The slope is 0. So actually at these points, the function is neither increasing nor decreasing. But it's going to have a horizontal tangent. So what we want to know then is, on those intervals between the critical points, what's it doing? Is it increasing or is it decreasing? So let me slide my work off to the side here. And what we're going to do is the same thing we did yesterday. We're going to make a sign chart. So we're going to look at the derivative, and we're going to look at the derivative on these intervals here. Now, this is actually going backwards a little bit. Yesterday we made this sign chart to figure out when a critical point is going to be a maximum or a minimum. Now we're just using the sign chart to figure out on which intervals it's increasing or decreasing. So this should be fairly straightforward, I think. Remember, these 2 points here are the only points where the sign can change from positive to negative on the derivative. So if I test any point to the left of negative 1, that's going to be the same as testing all the points as far as sign goes. So is the derivative going to be positive or negative to the left of negative 1? If I put in a really big negative number here, I like this version the best here. So we get a negative and a negative, so our derivative is going to be positive. How about a number between negative 1 and 5? How about 0? Then we're going to get a negative, right? And how about to the right of 5? It's going to be positive. All right, so to answer the question here, be sure that we're answering the question. We could right now answer the question about extrema. We could tell where there are local minimums and maximums, but we don't need to do that. The question says, where is it increasing? So it's increasing on what? Okay, so it's increasing on negative infinity to 1 and I'm sorry, negative 1. I'll fix that. And 5 to positive infinity. So the function is going to be increasing on those two intervals, and it's going to be decreasing on negative 1 to 5. Why am I writing these as open intervals? Why don't I include negative 1 and 5 on these intervals? Yeah, exactly. At negative 1 and 5, the function is neither increasing nor decreasing. It's actually going to have a horizontal tangent at those points. Okay, any questions about this? Like I said, this is kind of going backwards from what we've done. We used this exact same idea yesterday when we were deciding whether points were going to be minimums or maximums. So we should be okay with that. Any questions about this?